here on the first slide, just some basic contact information for me. It's all in the syllabus, and I got a few questions about this. So you're registered for 2 sections of AMAC 203. This is section 1, it's the lecture. And then you guys are divided into 4 different lab sections. So your other section number is your lab section. And it meets in Reed, but not in this room. It meets up in 302 upstairs, which is also the first time we've used that room. Because this class keeps getting bigger. So it's a room that's bigger than the PPS, or what is it called now? Barnard, whatever, building. So I have my office hours up there. I just wanted to point out that on Tuesdays I have the 2 morning labs for this class, and then I have this lecture. So there's an hour break between my lab and lecture, but it's about an hour break from 1 to 2. So I'm just going to stick around and hang out and read. If there's no one in the lab, I'll stay in there. If there's someone in the lab room, then I'll just be out there. I don't know, we'll figure it out. But that office hour is not in my office, it's somewhere in this building. So I'll get back to you when I determine what a good spot for that is. So today, we are going to go over how the course is structured in the syllabus and boring rules. And then we're going to start topic 1 as well. Just to give you a little plan. First I wanted to do some introductions. Introducing myself, but also getting some information about you guys as well. So this is my 2nd year at MSU. Come on in. Everyone will have to stand up when you find your seat. That's okay. So I started here last year. And before that, I was 4 years at a school in Connecticut called Fairfield University. I was faculty there. I did my undergrad in Minnesota at a liberal arts school called St. Thomas, but no one who doesn't live in Minnesota, no one's ever heard of it. And then I did my master's and PhD work at St. Boulder. I like to put up just some of the companies that I've worked for and just some of the industries I've worked for in case that's something that if any of them are of interest to you, you can chat with me about them, or if you need advising on any of that, grad school advising or those companies. My research is in computational fluid dynamics. So I'm teaching a class this semester it's a PE, a professional elective, or a graduate level class. It's co-listed. And it's actually going to eventually be, it's for maybe some of you, it's going to be a required class if you're on the newest flow chart. But that's my area of expertise, fluid dynamics, but all numerical and computational. So I love this class. It's my favorite class to teach. I am so into it. I'm so into it, it's getting bad. In fact, don't tell them yet, but I got all the TA's MATLABBasics this year. I'm giving them to them after this class. And so I'm really excited. Now, I'm going to pass these out. So you just do this throughout the lecture. You don't need to finish it. I'm not going to take a break. We don't have time. But just take a card, pass it around. Maybe I should take half of those. I just take half. That's half. And just this is optional. You do not have to provide any information about yourself. I'm not forcing you. But it's just having it on the card. It's just a quick way for me to learn something about you guys. I'll just keep them, hopefully being able to just kind of customize my thinking and my teaching towards your interests and your background and that kind of thing. There's so many of you. I won't know all of your names. It's so sad for me, but I can only do 75 a semester. It's like I've tested it. You can only learn 75 names, and that's usually total between all my classes. But I'm pretty good. I will try. And I'm really good with faces, and I'm really good with facts, but I'm just really bad with names. So on that note, please post a D2L photo of yourself so that I can get better. Just a few tips. Have it be of your face. Have it be of your face making a normal face. And have it be within the last year so that it looks like you. And I also post those photos up on the screen every single lab because they're used for the seating chart. So the photo should be comfortable to be on the projection screen. So I just give 2 points for posting that, just because if I don't, a lot of people don't do it. And so I'll put that in about 2 weeks. Okay. There's detailed course outcomes and course goals in the syllabus that I'm not going to go over, but I just like to mention that this class, the goal of this class is your first introduction to programming. Traditionally, in mechanical engineering curriculums, this class was taught in the computer science department. And I would say over the past 5 to 10 years, mechanical engineering programs have been putting it into their own department taught by mechanical engineering faculty. So you don't see programming anywhere else by default in the program. We're also going to learn how to use MATLAB, the software, as a tool, which I'll explain a little bit more about. It's a really good, just all around, just think of it like a calculator type tool, but much more than that. And then, in order to program, instead of doing, like in computer science, you might be learning how to program web pages or program software apps, or there could be a variety of applications. We are programming numerical methods and tools that you use to solve engineering problems. So you're going to see some first order applications of these numerical methods that you will then see higher order in 303, which is the class after this. So those are the 3 things that we're going to be doing in this class. I mentioned this sort of already. This is the flow chart. I didn't make it. This is just what it is. So I've highlighted the prereqs for this class here, which is Calc 1. A co-req is Calc 2, correct? So this is Calc 2. So this is a co-req, and then this is a prereq, but this is actually not, 103 is not a curricular prereq. So it was not placed as a prereq because you need the content before this class. It was placed for logistical reasons. They want to move you guys into the right places in the right years. So this is nothing like 103. And it bothers me because it also has the same name. But it doesn't really have anything to do with 103 other than the fact that we're both using computers. But a lot of people use computers now in classes. So I do get a lot of students who are like, I just expected this to be like 103 and this is like a lot harder, and it's totally different. So just erase 103 from your brain and just think of this as your programming class, okay? Nothing wrong with 103. I'm just saying it's not the same thing. After this class, this is a prereq for 303, which is then a prereq for lots of other classes. And then, like I said, from 303, you're then going to go on to computational fluid dynamics or finite element analysis, which is like solid mechanics, computational solid mechanics. So this is a sequence of things. So it's important that you get it now because it's like math. You're going to keep building on the skills that you're learning in this class. Okay, so all of the materials are available at the bookstore. And I sent an email about this, so I'm going to just briefly go over this. So I noticed, I went by the bookstore a couple weeks ago, actually several weeks ago, and I saw that this book was there, and then the sign said something like optional but strongly, really importantly recommended, like it had some all caps, like really intense superlatives. I did not put that there. The bookstore did. So it is an optional textbook, and that's it. It's always been required, but I've gotten a lot of complaints that everyone just prefers to Google things because MATLAB is a really, really popular thing right now, and there's just a lot of stuff on the internet. So you don't need to buy this if you don't want to. You can use an old version as well. This is the 4th edition. Just my chapters won't line up. And I think that's it. If you have any questions, I did design all of the content around this textbook. So it is very useful, but it's not required. The course packet is the next thing that you'll need to pick up. It's just you're paying for the printing, basically. I wrote this course packet, and it contains all of your assignments for this class. So pick it up. Hope you already have it. And then put it in a binder with dividers. The next thing is the software. All of the lab computers obviously already have MATLAB installed in them, but MATLAB is now free for students. They got a site license over the summer, and now all faculty and students can download for free. I apologize for any of you who previously asked me about that and had to purchase it because they did not tell me until the summer that they were buying a site license. So you guys are lucky because you used to have to pay $50 to $100 to buy the student version. So install it on your computer. Lots of people just use their computers in the labs and don't use the lab computers. So you're welcome to do that. That way you don't have to be transferring files back and forth. And you can download it on Mac or PC or Linux. Okay, and then obviously D2L is heavily used in this course, so I don't have time to like go over everything on D2L and everything in the syllabus. So I just want to say right now that it's your responsibility to review everything in the syllabus and everything on D2L. So there's like assignments that'll pop up like post your D2L photo and there's some deadline for it. That all should come up for you in D2L and you should just be doing that. I won't be able to announce every time and be very clear with the deadlines in this lecture. Okay, so let me just briefly explain the course setup. There's 12 topics in the course, and I have the topics listed here. For each topic, we do a lecture, then you do a pre-lab that you need to do before you come to lab, and the pre-lab is an extension of the lecture. I can't cover everything in the lecture, so I've written the pre-labs to kind of self-guide you through some of the topics. A lot of times, almost all the time, you need to be on MATLAB working through and trying things in the pre-lab. When you come to lab, you're going to do the programming lab, and you always have 2 lab sessions to complete the lab, but you will probably need to work on the lab outside of lab at times, not always. And it's very dependent on your own skill set and ability at this point. Because, by the way, we have a huge variety of student levels in this class because it's kind of a sequence that falls outside of all the other sequences in the MU program. So people can kind of take this class whenever they want. When you come to the next lecture, so after the first lab, then you have an iClicker quiz at the start of lecture on the topic that we did in the previous lecture. And then in the next lab, you have a quiz. It's very confusing. You'll get the hang of it, but in the schedule on the back of the syllabus, you'll see all of it laid out. So we're doing topic 1 this week. Next week is quiz 1. The quiz is the last 30 minutes of lab. It's a programming quiz on the computer, and it's all submitted and received through D2L. Do you guys have any questions about the course setup? Most importantly, Thursday lab people, like most importantly, you have to do your pre-lab before Thursday, this lab. All Tuesday lab people always have a full week before their pre-lab is due, after the first lecture, which is actually, I would say, a disadvantage because you have like a whole week before you do what we talked about. Grading-wise, the course is broken up into these weights. The iClicker quizzes and participation are 10% of your grade. So the iClickers are graded. You get 1 point for answering the clicker and you get 1 point for getting it correct. But then you also get points for all of your attendance. So every time you come into lab, you get 2 points. So the majority of this grade is just participation, and I've never figured out the percentage, but then some percentage of it is correctness on the clickers. Then 20% is quizzes, 20% is all of the assignments that you're doing, the pre-labs and the labs. And then there's a midterm exam and a final exam. The exams are all evening exams, and they're during common hours, so check the schedule and schedule that in schedule it into your own planner. They are handwritten, no computers, no electronics, and they're closed book, closed notes. The only thing you can use is your toolbox cards. So if you picked up your course packet, you should have gotten a bunch of yellow note cards, 1 for each topic. You can write whatever you want on either side of those cards, and that's what you can use on the exams. Is there any questions about that? All right, so for those of you who have your clickers, if you could get them out, I'm going to collect your clicker data right now. I'm going to post it to D2L so that this is kind of like a tester for you to see if it's working, if everything is going okay. This doesn't count against you if you don't have your clicker this time, but it will next time. So go ahead and answer the question, where are you from? I know that's like, sometimes I don't like when people ask me where I'm from because I've moved around so much, but you know, just answer whatever your heart is telling you. I don't know if it'll let me show this. I can actually show you what I see if you guys have never used clickers in any of your classes. Yep. Yeah, the syllabus is up there. Is anyone having any problems with their clicker right now that you want me to come look at? Okay, so generally I'm going to ask the clicker question, and then I'll usually say something like, okay, make sure you click in. I'm going to stop the responses. And then I give you another couple seconds, and then I'll say, okay, I'm stopping the responses. And then I stop it, and then you can't click in anymore. So I'm going to stop the responses right now. I have 107 responses. And I don't show this, you know, because usually that would give away the answer. This is the responses in case you're interested for this question. Okay, so I will post this to D2L so you'll see what it looks like for me to receive your response. I'll count this as bonus participation, and then next time this is all going to be required, so make sure you get your clickers figured out. One thing is that you have to re-register your clicker every semester. So if you used it last semester, you still have to re-register it through the syllabus link. So if you don't have data up, if it says that you weren't here and you didn't click in, you'll need to re-register, and I have to resync and update everything manually. So I'm not going to do it unless you tell me that it's not working. Okay, so this class is very fortunate to have the help of 7 undergraduate teaching assistants, which might not be enough. We'll see. We might have to get some more. And 4 of them helped last year, and the other 3 took it last semester. So I like to have a good mix. You can see who has which lab. The Tuesday labs and the Thursday lab all have 3 TAs, and the Friday lab currently only has 2 because it's not full. And the TAs are also holding some optional help sessions, always held in a computer lab. So the first help session is going to happen this Wednesday, so tomorrow, because if anyone needs help with the pre-lab, Seth is going to start his help sessions on Wednesday, and then they'll just continue every week. I don't expect there to be any problems, but I just want you to know that the undergrad TAs all are basically under the same umbrella that every other instructor is in the student handbook. So I expect you to teach them, treat them with the same respect that you would treat me and that you would treat your peers. The big thing is if you have any content questions that you don't feel like they're able to answer, it's not appropriate to question them or make them feel like they should know something. They're not instructors, they're teaching assistants. They're here to help you in any way they can. So come to me and ask me if they aren't able to help you, and it's not a big deal and it's not their responsibility. Secondly, if you have a grading question and you are basically wanting to question their grading, unless it's a straightforward question, if there's any sort of decision making that needs to happen, you need to come to me and again, not make them be in that position to make that decision. That's not their role in the class. Their role here is to help you guys and explain things to you guys in any way that they can that might help you that I am not able to do. Any questions about that? They do help with a lot of grading as well, but I design all the rubrics that they're grading for, so they are not making decisions on your grade. They're just applying a rubric. Okay, so the next couple things I have to say are my least favorite things, but I have to talk about them. So I'm going to highlight a couple important policies in the syllabus. The first policy I have is just your presence in lab and your presence in lecture. So out of respect for myself, for your peers, and for the TAs, I want you to be in lecture and in lab using the time productively and wisely. If there's absolutely nothing that you feel that you can do with the time in class, you can work on a different assignment for a different class. That's fine, but that almost has never happened. I know that you guys all need to use your cell phones for various things, but I don't want you using your cell phones for excessive texting or excessive off-course stuff. Same with computers. It's just distracting, and it just creates kind of a negative environment in the lab and in the classroom. I already mentioned the exams, so make sure you check with that. If you are not available for any of the exams and it's an excused reason, so there's a couple of reasons that you cannot make it to a common hour exam, you need to contact me by the third week of class so we can make alternative plans. We talked about exams. There's no exam or quiz makeups if you miss them, unless you've made arrangements prior to the exam or quiz time. There's no late assignments accepted. If they're not turned in by the deadline, then you don't get credit for them. And then if you have any question about the way something was graded, probably an exam, maybe a quiz, we ask that you come to, if it's for me, that you submit it in writing by email within 3 days that it was returned. This policy is in place because students will come to you at the end of semester when their grade isn't what they thought it would be, with all of these questions about how things were graded, and that's what we're avoiding. So you need to come within 3 days that it was returned. The discussion doesn't need to happen within 3 days, but the initial email needs to happen within 3 days, and then we will set up a time to chat. Okay. The last thing, and there is a whole section about this in the syllabus, and so you should read it carefully. This class, and I guess the program in general, has been having a lot of problems with academic misconduct. So we're trying to be very clear at the beginning of the semester of what's allowed and what's not allowed. They actually collect data of how many academic misconduct cases have been reported over the past years, and it's like this. Like, it's just growing, and we don't know exactly why. But we need to be very clear about what is allowed so that you understand what is allowed. So I want to define what collaboration is, okay? So collaboration on assignments like pre-lab and lab is allowed, but it is limited exclusively to discussions, verbal discussions, written discussions, demos on the computer. Things that are not allowed with pre-labs or labs is sending files. You should never be sending or receiving files to anyone for any assignment in this class, ever. You should never be getting files from anyone, a previous student, taking files from the internet. Those are all defined as academic misconduct. And I understand how it is confusing, and so I'm just defining it for you. On quizzes and exams, there is zero collaboration allowed ever, unless it's explicitly said at the beginning of the quiz. Okay? So collaboration is completely not allowed. Everything needs to come from you and your fingers. So that's the definition. All files are submitted to Turnitin, and so they will all be checked for originality and pure collaboration. They get checked with everything on the internet, all files submitted any semester, so all past semesters are checked, and all current students. So it just checks the similarity of your M files with every other M file that's ever been submitted and on the internet. So that's just a way to just check. And then as for the penalty, all academic misconduct is reported to the Dean of Students. Anything is reported to the Dean of Students. And the penalty for this class is whatever whatever assignment, quiz, or exam that it happened on will be given a 0%. That will be the minimum penalty. It really depends on the situation. And then That's for the first offense. Second offense is a 0 in the class. And then if you have 2 offenses to the dean of students, there are other consequences. So I just control this class, and I have my own policies for this class. So sorry that I have to talk about it, but those are the rules. And we've been having a great time in this class. It's not been a big problem, and so I just want to make sure we're clear. Okay? Okay. Here's the schedule, blurry schedule. You probably can't even see it. It's in the syllabus. This is something you need to be very comfortable with and understand when things are happening. Just like look at it a little bit. It'll make more sense. And this really kind of will guide you through the class. All right, so that's the class. Does anyone have any questions before I move on to a little bit of lecture on topic 1? Yeah. Yeah, okay, so it is in a kind of a strange place. The syllabus is in the overview. If you click on overview, it's just a document that will show up in overview. Yeah. Any other questions? Okay. You'll see in the syllabus that I've actually given you, I know that it's very useful. So I'm going to continue to do that. But it is a little bit clunky because I have to switch chords and stuff. But I think it's useful, so I'm going to continue to do it. All right. So today we're going to be talking about MATLABBasics. I'm going to be showing a bunch of things on MATLAB. I have about 20 minutes, so I'm going to be going over several different things. Please keep in mind that I kind of give you a little taste of everything in lecture, and then you're always doing everything, and it's explained another time in the pre-lab, so don't feel overwhelmed to like write down every single thing that I am telling you about. Try to get more of the big picture stuff. So I like to talk about basically these four aspects of the class that are often confused in this lecture to just get you to kind of think about these things. The first thing is what we kind of already talked about as one of the course goals, which is that through this class you're going to learn, how does this look? Are you guys able to see it okay? This one's going to be a little small, but that's the recording. So you're going to learn how to program. So the way I like you to think about programming is you have these problems that you want to solve, engineering problems or whatever, mathematical problems. And programming is a way of converting human language or human mathematical language into something a computer can do. So it's kind of converting this very intense science and math that we're able to do as humans into something very, very simple that a computer is able to do with zeros and ones and addition and subtraction, basically. So that's kind of everything that we're doing. We're going to learn how to do variables and loops, conditional statements. We're going to learn how to structure data and basic arithmetic. And all of those skills are kind of allowing you to be able to program in general. The next thing is that you can't learn to program unless you learn a specific language. So programming is a general skill you're going to learn that I hope you can apply to a lot of different languages as you go on. But we are going to use the language of MATLAB. It's very similar to the C language if any of you have previous programming experience at all, or C++. And that's the language that we're choosing to use, the syntax that MATLAB understands. And so for example, if you need to use a loop, in MATLAB, the loops are called while loops or for loops. Those are how they communicate. That's how MATLAB knows that you need a loop. The next thing and this is by far the most difficult part of the class, is understanding how to take a problem, think about how you might solve it, and be able to formulate an algorithm, which requires this like kind of sense of logic. And I've spent a lot of time trying to figure out how to teach that. It's very difficult, and it doesn't require programming. It requires the actual solution, if that makes sense. So it's like formulating the order of the steps that you would need to take in order to solve the problem. And people have a lot of different experiences with logic and algorithms, and so that's the challenge, is that everyone is at a very different place. And then the last thing is maybe the most exciting thing for a lot of people, depending on your interest in programming, is getting familiar with the MATLAB software and the MATLAB environment, because it is not just a programming language. It is a tool that can do so many things, and we are going to be introducing you to a few different things that it can do. But it really takes off a lot. There's all these toolboxes that we don't use hardly any of them in this class, but some classes use them. It's a post-processing tool, it's a calculator, it's a calculation, more sophisticated calculation tool than a calculator. So it's so much more than just that, and you're going to get a lot of experience with that as well. Okay. So what I'm going to do is I'm going to move over to, oh, I forgot I could do both here. Oh, I can't yet because I have 2 boards. This is the first time I've had 2 screens, so I'm planning to be writing notes and showing you MATLAB at the same time, but I actually cannot do that at this very moment because I don't have enough cords. But I want to just show you a little bit about MATLAB. So all of this you're going to redo in your pre-lab, but this will just give you the first kind of look at it, okay? So first I wanted to familiarize you with the environment. So this is what MATLAB looks like when you open it up. I did download the 2016 version. You could actually have any version of MATLAB. We're not really doing anything that will require us to be on the same version. Although it did change in like 2014 or something, 2013. So if you use an old version, it looks very different, but it's been the same for several years. All right, so here are the main things I wanted you to see. So this is your active folder that you're working in. So if you're running any files, or if you are accessing any data, it needs to be in this folder. So if I want to run a script file that I've written, I can only run these ones right here, or I have to create a direct path to those. So this tells you where you are. It also shows it here. So I'm in my desktop under a folder that I created. This is the command window. This window right here, and this is where you can basically try out some code, or if you want to try out a couple lines of code, or if you just need to do a quick calculation, use the command window. So you can use it to just do basic math, all of the arithmetic symbols are obvious. It's all the ones that it normally is. There's also a bunch of intrinsic trig functions or other functions that exist that you can call from the command window. For example, you can take the sign of a number. It's supposed to be 0. It's a computer, so that's what it's giving you. But the sign function that I just used, that's the name that the function's called. We'll learn a lot about these things. And then in parentheses, if you want to input something to that function, you just have to put parentheses around it. So I did pi, I could do 0, and the function sin, S-I-N, is the radians version of the function. But there's also a function called, well, how does this look? Is that big enough, that text, for the back people? Okay, I can make it a little bit bigger. Just come talk to me after class if you're not able to see anything. And then sin d is the degrees. And a lot of them are just what you would think it is. So if I am asking you to do something like I give you an equation and it has an exponential in it, you'll just have to Google it and find what the intrinsic function is for an exponential. Or just try it. One trick is you can start typing something like I want the exponential function, so I'm going to start typing exponential. And then I just press tab, and it autofills with all the functions that start with EX. There's a lot. I didn't know that would be the case, but it is EXP. So if I tab over, I see that that's the first match, and then all the rest that have EXP in it. So to do that shortcut, I press tab. Other shortcuts that are really useful are the up and down keys. So I'm pressing up right now, and it's paging through all of my, there's quiz 12 solution. All of my previous commands that I've executed, and even dates and time steps stamps it. So you don't ever have to retype things. Like if you wanted to redo this and put in a different number, you don't need to retype it, just press up and edit the line. A couple other little quick things. Before I show you some more in the command window, which I do want to show you, another window is the workspace window. So the workspace window is going to show you everything that MATLAB knows about at that moment. So typically the stuff that we're doing, we're going to be saving our calculations to variables. So if you go back up to this first very complicated calculation that I did, 2 times 3, we wouldn't do that. We would actually define our numbers that we're trying to multiply to variables. So I gave 2 to A and 3 to B. And then if I want to calculate 2 times 3, you would never do this, but you know what I mean, I'm just giving you an example. Then you would use the call on the variables and give those to another variable. So you can see here in the workspace that when you save things as variables, then you can call back onto them and they're all going to show up in your workspace. So you know what MATLAB knows about, which is important, but you also know a little bit more about what is held in that variable. So we're not only going to be dealing with numbers, we're also going to be dealing with character strings, and then next topic we're going to be dealing with arrays, which are variables that are holding a lot of numbers, not just one number. So this is a quick look at what it knows about and what is in it. Let's see. A couple other quick things. You're going to need to be writing M files for almost everything that we're doing. So that's what most of your programming labs will be. So what is an M file? So if you click on New Script, it's just this button in the left corner here. You can click there, or you can actually click New, and there's a couple different options. You can click Script, which does the same as New Script, or you can click Function, which will autofill the function declaration line, which we don't get to until much later in the semester. You can also just do File New, so there's a couple different ways you can open a new file. So what you do in a script file is you can run a series of commands instead of just one at a time in the command window. So instead of doing the 3 lines of code that I just showed you, I can put them all in the script file and then save the script file. I use that. Just replace it. And what it will do is it will execute from top to bottom, left to right, all of the code that you put in the file. So to run it, you can click Run here. And what you'll see is in the command window, the name that I named that M file shows up. And when the arrows come back, that means that script was executed. Now nothing happened because I put semicolons behind all of my commands. Semicolons will suppress the output. So for example, if I do A equals 2, it will show me the result of that calculation or variable definition. But if I do A equals 2 semicolon, it will suppress the output so nothing gets printed to the screen. So programming practice is to suppress all lines of code and only show lines of code that you need to see. Otherwise, when you run your script, if there's 300 lines of code, you won't see 300 lines of output. You'll just see the things that are important. So a script file allows you to do that, but because I suppressed all my lines of code, you don't see anything when it's run. And then, let's see. Another way that you could run the code is to, instead of pressing the Run button, you can type the name of the file. So because the name of the file, since we're in the current folder, you can see the name of the file here. You can just type exactly what the file is named and it runs the code. So that we can see that this is working, I'm going to unsuppress the last line so we can see that last calculation. And you can see when I run it with the Run button, that C shows up, that definition, that calculation. And then the other way is to type test into the command window, press enter, and it does the same thing. The autofill also works for the files that you've created. So if I start typing test, any file that's in that folder that MATLAB has access to will show up. One thing that I want you to keep in mind, especially if you're using your own computer with its independent operating system, is that the way that MATLAB accesses files is different depending on the system. So some computers are very good at finding files. So even if the file isn't in the folder, it'll actually go around and find the file, which is that's actually very dangerous, but it can do that. and some can't. So there's a little exercise in the pre-lab that helps you determine whether or not your computer can do that or not, so you can be aware of it. Let's see. Okay, so you're going to do a lot more of that. The next thing I want to show you is something that's actually in your packet. I think you probably all saw this, but I actually did a very thorough summary of each topic. This is new this semester, so let me know how you like it. It just it's very thorough, like everything that you should be able to do by the end of each topic. It gives you reading, extra practice, and it summarizes the algorithms that you wrote in that topic, which is really useful. Okay, so what I wanted to show you here is if you go to your pre-lab, at the back of every pre-lab, it'll be the last page of every pre-lab. And this is kind of going back to that discussion I was trying to give you on algorithms versus programming, all that kind of stuff. I've taught this class, this is like maybe the 6th time I've taught it. So through the many iterations of like working with students on programming, especially students who have never programmed before, I realized that when I give students a problem, like, okay, here's an engineering problem to solve. Calculate the volume of something. That's like an easy one, but you know. It's like they know how to do the problem, but they're overwhelmed by how to convert that into a MATLAB script to do the problem, if that makes sense. So these steps I've developed through the years of trying to give you a place to start if that's very difficult for you. So the idea is before you come into lab, part of your pre-lab is to complete this. Everyone is going to do this very differently, and I'm not trying to give you a formulaic way of doing this. I'm trying to give you a lot of ideas of what might work for you. If you are a very good programmer and it's very easy for you, you might just need to go from step 0 to step 1 to step 5, for example. If it's something that just you aren't able to make the connections, you might need to go through each step every single time, and maybe after a couple classes of programming, this will be easier for you and you can skip some steps. But the idea is to sort of define the procedure that happens every single lab. So first you need to read through the whole lab, and there's a lot of words because I wrote them in a step way. So I give you steps rather than giving you the global picture of what you're trying to do. So you'll have to read through it, and then you'll need to think, okay, how would I solve this problem if I was given this problem with more smaller size data, or if it was simpler, if it was more simple, if the math was simpler, if there was less numbers, anything, how would I solve it as a human, and write down those steps. Then you just go through and take each of those human steps and convert them into what a computer can do, and that's step 2. Step 3 is now take all those computer steps that you were able to convert to and rearrange them and put them in an order that creates a pseudocode or an algorithm. And don't be picky about syntax or anything like that. Just try to order the way that those steps would need to take place. They often need to be nested. And then the last step is translating your code into MATLAB syntax. So I need to find the maximum of this array. I know I need to find that, but what's the syntax to find the maximum? And I'm going to show you these steps. I'm going to give you examples. I'm not doing it for this lab because this lab is very simple, and you might be like, why do I need to do this for an array for a calculation? All I need to do is calculate the volume of something. Why would I need to go through all these steps? But do it just so you can have a practice at it, and ask me questions during lab. Ask the TAs questions. And the idea is that you come into lab prepared to do the lab. You're not sitting there never looking at it yet. And you can ask us questions right away, because this is a tip for you. If you are ready to have something checked off in lab, or if you have a question and you come to lab with those questions at the beginning, it will definitely get answered. If you are waiting towards the end of lab right before the quiz, we often don't get to you. So being prepared has huge advantages because the course was set up to be assertive. Also, Jacqueline's here. Just let's introduce her. She's TA. Sorry, Jacqueline.
Oh, no, you're fine.
She just came in. Jacqueline is one of the TAs. So you're Tuesday,
Yeah,
or
so
late
1
morning.
to 11.
So if you're in the lab 3, Tuesday at 11, you'll have Jacqueline. She took the class last semester, and I think that's it. Do you guys have any questions for me? Yeah. What's that? All computers on campus have stuff.